Okay. So, we got the remedials! Alright, so before we get into the content of the video, I'd like to introduce you to our new character. So first up, we got the Ivan the Terrible. Second, we got Jeff the Katarrian. And me, the Khwarizmian. So let's get into the basics, shall we? So there are many properties that indicates alkene, but there is one property you need and you have to know. Yes, that kind of formula. Although there are many properties such as double covalent, sigma N1p bond, sp2 hybridization, unsaturated hydrocarbon, and is the synthesis of alcohols, plastics, lacquers, detergents, and fuels. But CnH2n is what makes it obvious enough to identify. Compounds such as ethene and propene are the examples of CnH2n formula. The formula C2H4 and C3H6 follows this CnH2n formula. And also I forgot to mention it ends with E and E, which make them obviously alkene. So yeah, that's basically the introduction. Wait, what? I'm sorry, but you need to answer at least 2 questions before you leave. Guys, so we got the questions here, and so we're going to answer it here right now. Okay, so that basically the questions, and yeah, so the questions is draw the structures of ethene showing all atoms and all bonds. So yeah, it's very simple. So we just need to these and then this one H here, and then H here, and then double bond here, and so H here, and then this H here. Okay, so this is the next question, so we're just gonna wait. Oh yeah, I mean this is the next questions. Yes. So yeah, as you can see right here, we got the what is the general formula of alkenes? So yeah, it's pretty simple. You just need to write CnH2n. So yeah, that's it. Next up, it will be explained by this guy.
No.
Assalamualaikum. Today I will talk about alkenes, specifically alkenes addition reaction. I am not a creative person, so bear with me. So let's go. First, let us talk about addition of hydrogen, H2. Ethene reacts with hydrogen in the presence of finely divided nickel catalyst at a temperature of about 150 degrees Celsius. Ethane is produced, which is fairly pointless because ethene is far more useful compound than ethane is. And this here is the equation. So how does the mechanism work on hydrogen addition of hydrogen? Well, the ethene has a double bond, and since this is addition, the double bond breaks. And when add with hydrogen, each carbon atom will bond with the hydrogen atom, you see. Next, let us talk about addition polymerization. Alkenes can be made to join together in the presence of high pressure and suitable catalyst. The B bond breaks and the molecules join together. No other product is formed, and so this is known as addition polymerization. Since the polymers are made up of alkenes, they are also known as polyalkenes. Here we have the monomer, which is the ethene, and the repeating unit. Polymer molecules are created by the addition of monomers through the repeating unit. The mechanism works almost the same like hydrogen. The double bond breaks, and since we go through the repeating unit, it forms a single bond from each of the carbon atoms. So, as you can see here, the ethene, which is the monomer, turns into the repeating unit, and then they join together to become the polymer molecules, which are named polyethene since the monomers are ethene. Okay? Now, this is just an example of addition polymerization. I recommend you to pause and read because important, but and a bit of an FYI. Practice question time. But do not worry, I will give you easy question and you will for sure understand. First question. Which row describes the formation of polymer? If your answer is D, you are correct. Congratulations. Because ethene is the monomer and therefore the polymer should be polyethene. Next question. Molecules of a substance react together as shown. Which type of reaction has taken place? If your answer is C, congratulations, you are correct. You see, that right there is a monomer. And that is a polymer. It would only make sense if this is a polymerization reaction. Next, which substance is a natural polymer? If your answer is D, you are correct, congratulations. Now, if you were paying attention to the example of polymer and monomer, you would get the right answer. And finally, the last question. Which molecule can be polymerized? Now, if your answer is C, you are right again. Now, in order for a monomer to bond with itself to make a polymer, it will have to break its double bond. The bond should be a carbon atom, double bond. So, yeah. And there you have it. We are done. Now, was it too complicated? Did you not get it? Rewind the video and watch it again. Hehe. Now, thank you for your attention. I hope you all have a great day. Wassalamualaikum warahmatullahi wabarakatuh.
Hello and welcome to the next part. It is called Electrophilic addition of alkenes. So, first things first, what is an electrophilic addition? Well, electrophilic addition is a reaction in which a substrate is initially attached by an electrophile and the other result is the addition of one or more relatively simple molecules across a multiple bond. As you can see, it is simply a double bond C to a single bond C by adding an electrophile, hence the name electrophilic addition. Next, how does it work? The double bond in ethene is formed from a sigma and a V bond, which have 4 electrons in total. Although ethene is a non-polar molecule, there is a high density of electron area around the double bond C. This makes alkenes vulnerable to electrophiles. What's an electrophile, you ask? Well, electrophile is an acceptor of a pair of electrons. Here, as you can see in the example, ethene and hydrobromide. Hydrobromide is a polar molecule. In hydrobromide, the hydrogen atom carries a partial positive charge. In this case, the hydrogen atom acts as an electrophile accepting a pair of electrons from the double bond C. And in this picture, as you can see, the double bond is broken to a single bond. Next, mechanisms. Here we see mechanisms of an electrophilic addition. There is ethane and hydrobromine. I will explain this. In a bromide molecule, bromide is a non-polar molecule. It can act as an electrophile as well. As bromide molecule approaches an ethane, the area of high density of electrons around the double bond C repels the pair of electrons in bromide-bromide bond away from the nearest Br atom. This makes the nearest Br atom slightly positive and the farthest Br atom slightly negative. As the new bond between C and bromide atom forms, the bromide-bromide bond breaks heterolytically. The negative bromide ion form then attacks the highly reactive carbocation intermediate. Hence, one bromide atom bonds to each atom, producing 1,2-dibromoethane. Next, here we see a question example. This question is from Chemistry Cambridge 9/June/May/June/2019 Q12. So, in this question example, we see 3-methyl but 1-ene can undergo different types of reaction. See reaction 1 and reaction 2, which row correctly identifies the reaction types. For reaction 2, the double bond breaks and then forms bond from chloride and chloride. Chloride is in one group from bromide. So, this reaction is similar to the mechanism reaction in the previous slide. In the first reaction, the double bond breaks and then forms a single bond. This reaction is called reduction, as the double bond breaks and then forms a single bond. Hence, the answer to this question is C. Yay! We have learned electrophilic addition. Hooray for us!